Hello, everybody. I'm Sarah. I'm a senior product designer on Microsoft's inclusive human-centered design team.
And I'm Ivana Ilic. Sarah and I are on the same team. I'm a human factors engineer. So I focus solely on cognition, which is really about how people think, perceive, and interact with technology. And so Sarah and I today are going to be sharing how we as a team come together to combine human factors and inclusive design at Microsoft. So before we get started, I just want to go over what we'll be talking about today. First, we want to talk about what human-centered design is at Microsoft. Again, how we combine inclusive design and human factors at the company. And then the rest of the time, we're going to be talking about stories, lessons, and tactics that you yourself can take away to actually take inclusive action, no matter what your role is or where you're working. So first, I want to just ground us in what Microsoft's mission statement actually is, and that's to empower every person and every organization on the planet to achieve more. And when you think about that, that actually includes over 1.3 billion people around the world living with a disability. So that's about 1 in 6 people. So when we're designing on our team, we're really trying to design for one so then we can extend to many.
So before we dive in, I want to show you the space that all of this happens in, and that's the Inclusive Tech Lab. So to show you the inside of the space, I'm going to play a quick video of Dave Dame, our Director of Inclusive Design.
Hello, I'm Dave Dame, Senior Director of Human-Centered Design on Microsoft. My team is responsible for the Inclusive Tech Lab, and we do multifaceted human-centered design, whether it's inclusive design, where we're designing for people with disabilities, or if we're looking at human factors, ergonomics, or cognitive sciences. We're centered around where the technology meets the human and not the other way around. Inclusive design is as much about the human as it is in the product, and we usually want to learn and understand and hear these things. We needed a space that was dedicated for the disability community, where they can come and bring their best selves and we can learn from working with them to understand what it is that is needed and then help them understand what could even be possible. Realize the products you see reflect hours on hours on hours of working directly with people with disabilities. The products become an element of what we've learned from them. But the real story is how we've enabled their lives, how they can learn, how they can work, how they can live, and how they can play.
So now I want to share a little bit more about what human factors is. So human factors is really about empowering people to do the best work that they can while also feeling good doing it. So within human factors, we take a look at the physical, the mental, and emotional states of humans, and then also combine that with a variety of different disciplines like engineering, psychology, design, and ergonomics to shape products, tools, and the environments that people actually work in.
On the other side of the team, we follow 3 principles whenever we're designing products. So the first one is recognizing exclusion, and that means that we acknowledge the bias and the exclusions that happen between users and the products that Microsoft is creating. The second is learning from diversity, and in that we acknowledge that everybody's different. They come from different abilities, backgrounds, anything basically. And it's not just a box to check on our checklist of product design. It's taking all of those differences and applying it into the end goal so that it's better for everybody involved. And then lastly, the biggest one is solving for one, extending to many. So basically what that one means is whenever we create products for someone with a disability, it ends up benefiting everybody else. So one of the big examples of this is the curb cut effect. Whenever we were building sidewalks, we inserted a ramp into the sidewalk for users with wheelchairs, but that actually ended up benefiting everybody with rolling strollers or like baggage. Another example is the keyboard. So the first keyboard was actually made for low vision users, for people that read Braille. So we kind of went into our process and what our teams do, but what you don't usually see in the end goal of the products is the actual team behind it. So as much effort that we put into our team or into our products, we actually put into our team. So the humans behind the team are on the right side of the screen, And this is just kind of us going on events and stuff, but we put a lot of work into the interconnectedness of the people behind the team. So with all of that in mind, we want to dive into some of the products that our team has created. And you're probably wondering why I have a sheet of stickers on the screen right now, and I'm going to tell you why. So this is the Surface Adaptive Kit, and it's basically a kit of a bunch of sheets of stickers. And this is a really good example of how our team took a device that we built and we augmented it after release. So basically, if you don't know what a Surface laptop is, it's like the Microsoft brand of laptops. Whenever users that were low vision or blind went from desktop keyboards to laptop keyboards, they got a lot smaller. So they lost a lot of the tactile navigation that they had on that larger keyboard. So what our team did was we held a inclusive design sprint in the Inclusive Tech Lab. And typically what we do in these sprints is we bring in a group of disabled users and we try to get like a variety of disabilities and learn from them and apply that to our products. So what we did here, these are two examples of users, not the real people, obviously. But one of the first users that we talked to was Mark. And he was a game designer with limited motor control. And what he would do was he would augment his device with things like shims or cardboard and duct tape. And he really wanted something that could help him that was more not crafted and something that wouldn't damage his device. And then kind of same with Steve. He was a data scientist who was almost completely sightless, and he was a touch typist. So he would put bump stickers all over his keyboard. And what would happen when he did that was it would damage the screen of his laptop when he would close it. So in the middle, we have examples. After talking to these users, we actually started prototyping some ideas of how we could help them augment their devices in a safer and more beautiful way. So on the left, we have an example of a prototype of a pull tab. So one of our designers came up with this thing that you could put your finger through and open your device. And then on the right, we have our two cable stickers. So they're basically tactile stickers that you can put on your device and then match it to the port that goes into the wire. So by the end of the sprint, this is the full kit that we had. On the upper left is the final design of that pull tab that we showed. On the upper right are some clear bump stickers. We'll go into that in a second. And then on the bottom left are the colorful bump stickers. And on the bottom right are the final designs of those wire covers that we showed. So the top right is clear because we wanted to give users a chance to augment their device without changing the stylistic choices of it. So, and we also wanted to reduce stigma. But the bottom left is intentionally designed with the Surface ecosystem colors. So we've chosen all of these colors to go in line with the products that were launched at that moment. So the next product that I want to show is the Surface Pro Flex keyboard. And on first glance, does anybody really know why this is an assistive tech or why I'm showing this? If you said no, that's good. That means our design worked. So now that it's next to the standard keyboard, can you tell the difference? Awesome. So this is a great example of early phase synergy between our teams and industrial design and like hardware. Everybody came together to make this thing happen. So basically what we did was we made this keyboard bolder and higher contrast for low vision users to begin with. But by starting with low vision users, we actually ended up making this product better for people in dimmer environments. And it was easier for them to see because this keyboard doesn't have a backlight. But additionally, we also replaced all of the keys that had text on it, so like Shift, Enter, with icons only. And that was inspired by our international keyboards. So we're taking learnings from every part of the company to benefit a wider range of people.
Thanks, Sarah. So I'm going to talk about the last two products. The first one that I want to talk about is our haptic touchpad. And this is really centered around what the idea of what Windows should actually feel like. So for us, when we were designing this, instead of just seeing things happen on the screen, we really wanted our users to feel what's happening underneath their fingers on our Surface devices. And so what this actually resulted in is our users having a smoother and more engaging navigation so that, sort of everyday interactions actually felt a lot better to them. Next, I wanted to share a quick video from a limb different individual.
So in order to preserve and give a chance to heal the things that are going on in my right hand, I need to be able to shift functions to my left, which traditionally touchpads are not responsive at all to the work I do here. And so what we've done here with adaptive touch on the new laptop studio with its new precision haptic touchpad is really quite amazing. So I turn on the adaptive touch mode here, and all of a sudden, I now have full mouse control. And with that, I can also go in and change settings to things like the right-click zone, which for me, I like a slightly larger one. I can adjust the amount of pressure needed to actually register a click. So for other folks with dexterity and mobility disabilities who may have very light strength and not be able to exert a lot of pressure, we can actually dial this down really low to make it possible for them to still get an effective click without hurting themselves.
This video does a really good example of just showcasing how customizable the adaptive touchpad is. And one other thing I want to highlight with this is that the adaptive touchpad actually does a really good job of showcasing the attention to detail that we put into everything that we create. So when we're actually creating the haptic touchpad, we spent over 1,300 hours in an acoustic chamber just to make sure that the click sounded right. We had more than 20 variations of the haptic touchpad, again, just to make sure that that click also felt right to all of our users. And then we also ran a bunch of studies to really fine tune the ergonomics of that. Because again, the click should feel very natural and effortless for people, no matter who they are or how they're actually using the haptic touchpad. And then finally, I want to end with our line of adaptive accessories. So these are built for a wide range of hand function needs. And what I really want to showcase here before I get into some of the details is that, when we're designing this for software, accessories are really easy to customize. Hardware is very difficult. So when it came to trying to figure out how to actually customize hardware, the thing that actually worked really well is 3D printing. That kind of changed the game for us. So with 3D printing, it really allowed people to customize the solutions that they needed, so it could really fit whatever work setup that they had or whatever function that they actually needed it to do. And to show what this looks like in real life, I want to share the story of Yara.
When Yara was born, doctors weren't certain whether she was going to make it. But with Yara's enormous perseverance, amazing doctors, the latest recuperation technologies, a lot of therapy, and a little miracle, she managed to surprise us all. New lightweight 3D printed orthotics empowered her to learn how to walk. A speech computer empowered her to improve her voice. Play, practice, patience, and innovation help Yara to unlock her full potential.
So one of the really cool things about this story is that the person narrating that is actually Yara's dad, who's also a Microsoft employee. So this all actually came about through a hackathon that we did. So he was able to create this for his daughter. And again, this kind of became a catalyst for how customizable this really is for all different types of users. So to dive in a little bit more, what I have on the screen right now is the ecosystem of all the different adaptive accessories. So every piece that I'm showing here on the screen is highly modular and adaptable, again, with 3D printed or swappable 3D printed parts. So again, every user, no matter what their needs are, can actually customize this to fit whatever they need. And one quick example I want to go through out of our ecosystem of accessories is the mouse. So the mouse is a really interesting case example because we really experimented with the friction so that whatever they need. And one quick example I want to go through out of our ecosystem of accessories is the mouse. So when we were designing this, finding the kind of right balance between these for the customization was actually pretty difficult. But the cool thing about this is that because there are a bunch of different teams working on this, it really kind of we're still able to kind of shape the products that we're building today based on some of the learnings that we had here.
So just a quick recap of everything that we went over. The first was the bold keyboard. And that was an example that was led by inclusive intent between all of the teams involved to augment a product that was in development. Next, we had the adaptive haptic touchpad, which was a technical enabled experience designed specifically for that. And then we had the adaptive kit, which was a retrofitted solution for an existing product. And then lastly, you just saw the adaptive hub and the kit, which was designed for human variation, and the hardware actually enabled open sourcing. So I want to leave you guys with inclusive design is a mindset. So it doesn't matter if you're a massive org like you would think of at Microsoft. Our team is only like maybe 5 or 6 people. So if you ask the right questions and you loop in the right users and you really learn from them and apply that in your work, you're going to make something that feels intentionally and truly human.
So what can you take back from all the content that Cher and I talked about today? So really we have 3 sort of steps that I think everyone can take. First is start with human capability. So focus on what humans can actually do, not what they can't do. Second is optimization or optimize for inclusion. Expand what already exists. So again, more people can actually use it. And then third, prove it small and scale it smart. By that, we just mean, start with something more targeted and then grow it into having broader impact. So let's keep building together. Thank you guys for coming to our talk. There's a few different ways we can connect here with our emails or via LinkedIn, and we're always happy to chat. So we'll take questions now in case anyone has any.
Hello? Okay, yeah.
Thank you. Hello. I had the opportunity to tour the Microsoft Inclusive Design Space, and yeah, it's really cool and exciting how you bring people in to use it. I'm just curious about, since repetitive stress injuries are so common, I definitely have one, and technology is evolving, and how is that part of your general realm of consideration? It seems like there hasn't been a ton of innovation in keyboards and mouses and like kind of recent times. So I'm curious just if you see anything there and the future of those kind of considerations of, ergonomics to help prevent repetitive stress injuries.
Ivana can speak to the human factor side, but I would love to speak to the lab side. We're always looking at mobility and how we can adjust our devices for limited mobility. In the lab, we do a lot of specific assistive tech for that, but a lot of it is a lot of the augmenting that you saw, like with the Surface Adaptive Kit and the 3D printed toppers. So as far as keyboards that are for people with limited mobility, we tend to actually direct them towards third party. And we help them find it and get set up, and then we get their entire setups ready for them. But do you want to?
No, that's great.
Oh, okay, sweet.